Hi viewers, I welcome you all to our Programming World channel. In this video, I will discuss about introduction of data structure. Then I will introduce about linked list, specifically the single linked list model and how we can implement single linked list. So now we move on to the introduction of data structure. So it means that how we can organize the data effectively in computer memory for providing the efficient data access. So simple examples are items are arranged in kitchen and also how the books are arranged in a library. So we have two types of data structure with respect to organizing the data. One is linear data structure and another one is non-linear data structure. So in this, first I would like to cover about linear data structure because this video which is focused on linked list. That's why I come up with what the linear data structure introduction. So the data which are arranged in a sequential manner, so that is what actually each data connected to its previous and also the next element. Okay. So here you can find the different linear data structure. One is what the linearity, that means the data which are arranged in a sequence, and also the working principle like inserting, deletion. It is what wherever you want to insert the elements, you can do it, and also you can remove the elements from any locations. So stack, it is also what the elements are arranged in a sequential manner, but it comes with a different working principle such as last in first out. Okay, and another one is what queue data structure. So it follows a working principle like first in first out. These data structures will be discussed in coming videos. So now I would like to discuss about what is linked list. So linked list in the sense the data which are stored in the form of nodes in computer memory. In the sense, the sequential addresses may not be used for locating the node. Okay, the randomly the memory locations are used for keeping the node, where the node which is having two parts. Okay, one is what the data part, and another one is what the link part. So here you can understand one thing: the link part which help us to connect the next node in the sequential data structure, whereas the data part it's about what we want to access in our application. So you can have n number of data part because the linked list can help you to implement some database like employee database where you want to have employee ID, employee name, and employee salary. So those are all the different data parts in a node, whereas the node can have only one link part which can be able to connect with the other nodes. Okay, so here this node structure which belongs to the single linked list model because the singly linked list, the term singly it represents what the node is having only one link part. Here we follow with what actually a next field which help us to connect with the next node in our data structure. So we have other types of linked list also, double linked list, whereas you can have two address fields. One is what the previous, and another one is what the next. So from the label system, you can understand previous node and also the next node of the current node can be connected. Circular linked list is what a different style. That means from the last node, you can jump to the first node for continuing your traversal operation. So now I come to the single linked list. As I already told you that the node can have two parts. One is what data part and link part. So here you can see the nodes are organized in a sequential manner. And here you can find two pointers. One is what header pointer, and one is the tail pointer. Header pointer which is indicating the first node because the compiler it wants to know from where the list has to be traversed. Okay, so the node data 10, which is what the header node, so where we have the header pointer, and the tail node, that is what the last node which consists of the data like 40, and it's in address field we have null. So here the null value in a node which is what indication to the compiler where the list which gets stopped. So here you can find a simple example I have given. So here the engine of a train, which is what acting as a header, whereas the last compartment, you can see the last compartment of our train, you can see X mark that represent what, like a null value. Okay, that means the end of the train. Okay, likewise. So how we can implement single linked list? So here, as I told you, we should have two parts in a data in a node for single linked list. Okay, one is what the data, another one is what actually the next field. So here I given a C structure based node structure struct node type data. So whereas you have to give int or character based on the kind of data you want to deal. And node star link, here link which is used to represent what actually the address field where you can connect the next node, or you can give the label like next also. Okay. So in the same way, I have given the node structure how it can be made in our Python. So when we go to what Python, we have to use class program class element to create our node structure in Python. So there you have to create a constructor like def init, so where you have to place the data and also the next field for having our node structure. But in our video, we will discuss completely about the C programming based implementation. Okay, so it may help you to understand about very detail how the implementation can be made for single linked list. So here, first of all, we have to create an empty list. Okay, so we have to start with the empty data structure. Then only you can identify, okay, which node can be a header node. That's why we follow this one. So to create an empty list in C, what we're doing is struct node star head, because the head pointer it has to be assigned as a null to represent the list is what empty. Okay, so in Python, what we do is self.head is equal to none. Okay, so such style of code which help us to what initialize our linked list as what empty. Okay, so I just listed what about the different operations we need. One is what is empty, insert node, find node, delete node, display list. These are all the common operations, but we will discuss few operations in this video. Later on, we will add few more operations, whatever is pending to cover for single linked list data structure. So here I would like to discuss about one model of insertion, that is what actually insert node at friend. So here you can see the way how we have to do. So first we have to check whether the list is empty. If the list is empty, the new node it becomes what head of the list. Okay, because if the list is empty, what node which is created as a new, definitely that will be the header of the node, header of the list. That's why. Then suppose the list is having some elements, some nodes. Then what happen is, so we have to give the address of the header node, I mean the address of the old node, to the link field of the new node or next field of the new node. Then the head pointer it has to be jumped to from the current node the new node. Okay, so these are the two steps we have to follow for what connecting the node at the front. Okay, so based on that I given a pseudo code and also a program with respect to C language. Okay, first we creating a new node with the help of a malloc function. Afterwards we take the input data and we verify whether head is equal to null. That means whether the list is empty. If list is empty, what we have to do is head is equal to n. That means we are assigning the new node as a header node. Okay. The else for it represent about the list which is having the nodes already. So we have to store the header node address in the link field of new node. Afterwards, we have to move the header pointer to the new node. That's why we have the statement like head is equal to n. So now I would like to show you the code. Okay, what I have made for making you to understand. Okay, so here you can see that stuck to yes node. Then I have given only one data field, that is what int data. You can have a number of data based on your application need. Okay, then I have used next instead of what actually link here, because single linked list was if I have only one address field, then it means what actually I can have the connection for connecting the next node. That's why I given like next. Then I assign head is equal to null to represent initially the list is what empty. Okay, then I have a function, a user defined function like create node, whereas the new node will be created and it will be returned to uh, wherever you call the create node function. Usually it may be called in the insert functions. It may return a pointer or address of node which is created as a new one. Okay, so here you can see struct s node star new node. Afterwards, new node is equal to the syntax. That means struct s node malloc size of struct s node. This statement which is required to allocate the memory dynamically for storing the node or data in our memory. Please understand one thing. So here, for each data, the node will be created, the memory will be allocated. Whereas in array, what happened in the sense, so we should know about what about the maximum number of data we are going to handle. Accordingly, we have to give the size to our array, the array structure. But when it comes to what the linked list, we have to allocate the memory for each data, okay, with respect to what actually the node structure, okay. So that's why we have like this. We have this dynamic memory allocation function. Afterwards, we take the data. Then finally, we assign null value to our new node next field. Okay, I'm using the dev C++ environment, so automatically it may return the address of the new node to the function which is calling the create node. So here you can find insert beginning operation. So whereas I creating a pointer like new nn, that is what new node, and I call the create node function. So create node function, it executes to allocate the memory for the new node, and it takes the data. Afterwards it will be returned to the address will be given to the pointer nn. After then I am verifying whether list is empty. Okay, if list is empty, so already we have seen that the new node, which is what actually header node. So new node will be the header node. That's why we have this statement. Yes, that means what? The list is having some nodes. Okay. So in that case, we have to assign. That means what? We have to connect the new engine to the old engine. That's why you see we connecting the old engine to the next field of what the new engine. So nn next is equal to header. Afterwards, we have to move the pointer because the driver has to move to the new engine. So head is equal to new node. Okay, this is the way. I have added display function here. This is about what actually a traversal operation. So the traversal operation, it needs a temporary pointer. Okay, so it starts with what? A head pointer. Okay, if head is equal to null, that means what the list is empty. So we cannot do any we cannot give any output. Okay, yes, that means what the list is having some data, and we have to use the condition like while temp not equal to null. Why we are using while here? Because our list may be in what different size. Okay, we don't have the limit here. We do not give like 100, that is the size of our list, like that. Okay, so due to that we are coming with what the while loop, where we have to use temp not equal to null, because we have to process the uh, entire list. That means all nodes in our linked list. That's why we are using this condition. Okay, then I'm using a structure like that. This is what this structure of display represent data field and also the address of the next node which is connected to the current node. Okay, that's why I have given this kind of style. Afterwards I'm using the arrow mark to represent like a chain connections among the nodes. Okay, so the last node may not have the chain connection. Okay, and this is a very important line, temp equal to temp next. Okay, so the temp pointer will be jumping from node to node. Okay, until it reach what? The last node. That's why we are using this statement in the while loop. Okay, then I have given all different kinds of operations. Actually, we come up with what? Insert beginning. Then second choice is about display operation. Then third operation is about what? Exit the program. Exit the execution of the program. Okay. So here we have to use while often because the choices to be repeated until you want to close our program. Okay. So now I go to execute this code. So from that you can understand. So it displays what about the different operations we have planned. So it asks the choice. I'm giving choice 1. So where I insert the data 10. Okay. If you want to display, if you call choice 2, what happens is it may display the node which is having the data 10 and next node 0. Here the null value which is what displayed as number here. That's why it is 0. Then when I call again the choice 1, it takes the new data 20. What happens is the data 20, it has to be placed before the node data 10. Okay. Now you can see that, yeah, you can see that the node data 20 which is placed before data 10. Okay, as like that you can add a number of nodes. Here we don't have any limitations about what how many nodes how many data you want to have in your list. That's the benefit of using linked list compared to what arrays. Okay, even the dynamic arrays, if even you go with dynamic arrays, there also we have to we should identify what about the maximum elements I want to process, and during the execution suppose you want to increase. Okay, then what happens is you have to reallocate the memory, but here we don't have any such kind of a problem. So you can increase the list whenever you want to insert any data, and also if you want to shrink the size of your list, you can remove the data wherever you want. That's the benefit of using linked list. Okay, I just before closing this, I want to add one more data. Okay, so 5, that's the data I'm going to insert. So now you can see the data 5 which is inserted before 20. Okay, so here the next node address, this represent the address of the node data 20. As like that, this address in the node 20 represent the address of the node data 10. Okay, so this is extra I have made here. This is what computer to computer, this value, I mean the address value will be different. Even if I go for my next execution of the same program, that address will be what different, because the random memory blocks will be used to locate the node to have the data. Okay, so now I give the case 3 to exit my program execution successfully. It is done. Okay, I hope you guys understand about how the single linked list program, which is what made using C programming. It is a very effective one when you learn the data structure programs using C, because you can understand each and every part of our data structure concepts with respect to the unique program statements, which can help you to implement the required operations, and also the different characteristics of your data structure. Okay, so thanks for watching this, and also please subscribe. I request viewers those who not subscribed so far, subscribe this channel, and also please watch more videos for improving your academic skills, and also uh, you can shine well in your future and also your life. Thank you all. Thank you once again.